And Faiza, and then I think lastly we'll ask Ravi, who is our judge today, to introduce himself.
Sounds good. Um, and yeah, sorry again, camera's not working, but I'm
Mhm.
Kylan, and I graduated from VCU 2021, and I've kind of since worked at a few different companies. My most recent one was Alaska Airlines, doing digital experimentation. It's a lot of fun, and I should be getting an offer like any day now for a startup called StoryShift.ai as an AI architect. Like we're finalizing all of that, so that's exciting. Additionally, I've got an app called Resume Revival that helps create tailored job application materials, and that's got some venture capital discussions brewing. So pretty exciting stuff.
Very nice. Faiza, you want to go next?
Hi everyone, I'm Faiza Nuzhat. I'm a recent graduate from Technical University of Ilmenau, which is in Germany. I shifted to Seattle like 3 months back, and yeah, I used to work there. Besides doing my masters, I used to work at a research institute in Germany, that's Fraunhofer. And yep, I'm just excited about my journey, starting my journey in Seattle.
Nice, very nice. Okay. Ravi, you want to say a few words and then we'll start with the presentation.
Yep. Hello, guys. This is Ravi. So I am working in Microsoft as a principal software engineer, and I have over 20 years of experience, 15 plus years as a software engineer in the software world. Before that, I served in military in Indian Air Force. Other than that, I also teach computer science in local high schools. Yeah, that's about it. And nice working with you as your judge for this hackathon.
Thanks. Yeah. So Kailan and Faiza, you can take it forward now. Yeah.
Cool. Faiza, I did make some very subtle changes since your last edits, and I actually don't think I pushed those, so I can share screen.
And Ravi, in the end, if it is, if you could stay a little longer and here, that's fine. I will drop off so that I can switch on the next one. Okay. Just giving you as a heads up.
Cool.
Yes,
So I just want to take a moment to confirm. Are we able to see?
Yes, we're able to see your screen.
Awesome. So yeah, we decided to focus on smart disaster response, in particular fires. And so the challenge with fires is that we have an increasing frequency of them and severity due to climate change, and traditional response methods suffer from delayed detection in remote areas, resource constraints during peak fire seasons, coordination difficulties in complex terrain, and limited ability to predict fire behavior. So to set out to solve the problem, we wanted to create like a sandbox environment to simulate fire. There's some pretty good algorithms that will kind of get you going. The Drossel Schwab algorithm in particular kind of gives you like a good baseline for fire traversal. And it gives you some scaffolding to kind of add some variables around like topology and wind conditions to kind of further, dial that in. But it goes so far as to factoring in the fact that forest fires will actually, produce its own kind of lightning, and so that'll start fires close to the initial kind of big fire, and also embers kind of travel and cross valleys, etc. One thing I'll call out is that we did not use any sort of like sophisticated kind of like geospatial type data so much as like in terms of tapping into like actual satellites. We took just we wanted to avoid for the sake of a hackathon rate limits with APIs, costs, etc. So this is actually the baseline scaffolding to like extract topology, use like a PNG image that actually represents elevation through different shades of like black and white, where black is sea level and the highest point in the image is represented in white. And so you get like this black and white image that you're able to extrapolate and sample and turn into a topology map. We then iterated over a population density map to basically be able to infer infrastructure with gray tiles, where if there's a if there's a high population density, you can assume with a high degree of probability that there's also infrastructure where people are. So we're able to use that as like a baseline to kind of drop infrastructure. And so the whole idea is, we've got this advanced simulation response. It detects fire early through sensor networks and satellite integration. Responds faster with pre-positioned autonomous drone stations. Protects smarter by using agentic coordination to prioritize critical infrastructure, and adapts continuously as the conditions change. So our hypothesis was that an autonomous multi-agent system would leverage real-time data and coordinate drone technology to significantly outperform traditional methods by enabling faster detection, more efficient resource allocation, adaptive response strategies, and ultimately minimizing property damage to enhance community safety. So how it works, the simulation overview, we've got, we use the 2025 Palisades fire scenario to showcase the real world impact. And actually, with that being said, I will go back to this image really quick. So there's a red dot here that actually starts as like the seed point every time you run the simulation. This is where the actual Palisades fire started. So yeah, this is topology of Palisades. I don't think I had covered that when I was speaking to this just a second ago. So realistic fire simulation, again, the models simulate the complex fire behavior with terrain, weather, and fuel data in mind. The whole idea is that we would use autonomous drones that would operate without human intervention to detect, assess, and respond to the threats. Collaborates and coordination. The autonomous drones would communicate to ensure efficient resource use. The scalability and resilience is that this could be easily expandable with additional drone stations and resilient to failures. So for the fire traversal simulation, our model incorporates, again, the topographical factors. So things like elevation and slope. Fire spreads about 4.5 times faster when it's going uphill. Slope direction interacts with the wind. That was kind of an interesting thing to kind of bake in. Terrain type, different terrain types will burn differently. And so in our case, we kind of simplified it where that's just infrastructure versus land. Weather conditions, we factored in real-time wind and humidity. So yeah, fire behavior dynamics, fuel characteristics, density is one of the variables that's being looked at. Again, moisture, fire states. So a fire state for, this is kind of going back to this mosaic representation. But so yeah, fire states, we've got burning, smoldering, burning infrastructure, empty, and these all basically will play into different probabilities of like fire traversal in neighboring states. And advanced behaviors, we've got spotting, which is where embers will jump across, have the ability to jump across barriers, and lightning strikes, which have the ability to kick up random ignitions within some sort of sensible range of the actual fire. So for firefighting interventions, of course, there's water drops, retardant drops, fire breaks, backfires. Ultimately, for like the drone solutioning, it just focuses on retardant drops. So the drone agency system is a network design where we have distributed drone stations in a grid pattern that are in a always ready state for immediate deployment. And autonomous decision making is used for threat detection, to identify risks to infrastructure, prioritize priority assessment, focus on imminent threats, and target selection, strategic positioning of retardant. The drone mission cycle is such that you've got the deployment from nearest available station, travel to the target location. There's some logic baked in to make some assumptions around like the drone speed to be able to actually get to the fire. Retardant application is placed at strategically calculated positions. In our implementation, it's a little bit of like a brute force kind of proximity based algorithm. We'll circle back to how that could actually be improved. But another thing to touch on with retardant is it has like a 48-hour lasting effect, and it actually kind of fades out on the simulation when you're running it after the 48 hours. Status reporting. The whole idea is that all of these things would work together and report their status back to an overall kind of coordinating system. So yeah, the simulation interface, there is a legend that can help speak to these things, but we've got green for vegetation and forest, gray for infrastructure, blue for water, red for burning, this kind of orangish color for smoldering, pink is for the retardant being applied, the brown is for digging a fire break, and blue is for where the drone stations are placed. And yeah, within the control panel, we do have visuals for actually being able to display like how much infrastructure is getting burned. And so we've got, yeah, time display, current simulation, date and time. One thing to note is this does, the simulation does time steps in 1 hour at a time, from January 7th to January 31st, which is when the actual Palisades fire stopped. Simulation controls give you the ability to start, pause, reset. There's a drone mode toggle that actually allows you to run the simulation without our drone implementation, and then you're actually able to run it with the drone implementation. And there's a burn map toggle, which actually gives you like an overlay of the actual Palisades fire, which kind of helps give you like a sense of calibration of our fire simulation against the actual fire that happened. So yeah, future improvements for the AI, because our drones kind of get deployed in like a proximity-based kind of more brute force algorithm, this implementation could definitely be enhanced. Basically setting up some sort of self-play mechanism for an AI system to be trained where the reward function is basically infrastructure being saved, maximizing the preservation of infrastructure, minimizing resource usage, and achieving early containment. But I guess hanging out here too really quick. I mean, all the scaffolding is basically already there in the code for, of course, this kind of AI agency to really be able to take over and enhance further. But for real world implementation, the technology enablers are satellite data integration. We have high resolution imagery and LiDAR. These things can all play into our ability to be able to get pretty good and accurate topology maps, Starlink connectivity. This kind of helps with just the communication in remote areas for a drone system like this to possibly be able to work. Early detection systems. Google Research has a FireSat constellation that detects wildfires. Um, yeah, as small as a classroom, basically. So, and within 20 minutes, that's a pretty key thing because, as we'll see with the fire simulations, there's a really big and bad cascading effect with fires. So, the earlier you can act on them, the more you're able to really beat back some of their kind of exponential uh, impacts. But yeah, and another enabler is real-time boundary tracking. This is also out of Google. They've got some wildfire tracking capabilities uh, to just be able to relay back boundary information every 10 to 15 minutes. We've, of course, have weather forecasting, our ability to actually forecast wind. So it would be reasonable to deploy the simulation leveraging that, and edge computing. So it's well within our capability, of course, to be able to have machine learning models running these drones for localized decision making. So that's the presentation. Of course, we can spend some time actually running the simulation. So this would be running it without any sort of drone agency. We've got these yellow lines again reflecting the wind vectors over time, and these should update kind of day by day. And there's some tooling here that actually allows you to drop retardant over the map. It has some cooldown periods to it, so it won't let you just like spam it and everything. That's trying to emulate um, real world conditions where you only have a certain number of planes that can fly out. They have some re-up time before you could use them again. Ultimately, this was us kind of exploring around with some different feature ideas and ways to kick around and solve this problem. We decided these were kind of cool features to gamify the simulation and just kept them in, but don't want to get too distracted speaking to that. But here I just turned on the drone mode, kind of bottom right corner. And again, these blue tiles here, they represent drone stations. So I'm going to start this here. And you will see that the drone stations that are active, they start flashing red. And again, this is proximity based. So they're detecting basically fire within range of their drones being able to deploy and dropping fire retardant. with the goal in mind of trying to preserve as much infrastructure as possible. And so where this current implementation fails a little bit short is when the fire does get to the point where it starts sprawling out, it begins overwhelming the drone systems. But of course, this could be refined too just by adding more drone towers to the implementation, or a more sophisticated algorithm where maybe you actually start having some of these satellite stations deploying fire retardant more early within their localities, their range abilities. So I know that was a lot, but that is probably about it for our presentation, short of there being questions.
That's a great presentation, Kyle. Um,
Yeah. Great presentation, guys. Yes.
Awesome, thanks.
Faisal, you have anything to share?
No, actually, he covered all the things. Great. Thank you.
Got it, got it. So, Kyle, I have a couple of questions on the architecture. I'm looking at your repo. Can you give me a quick insights where did you use AI agents in this one? That's what you said.
Say that again.
Use AI agents to detect the
So
fire and channel orchestrate the drones accordingly. Is that correct
we
understanding?
we were sort of loosely tying this kind of like network effect of drones and their ability to somewhat kind of communicate with each other and
Mhm.
their various deployments um, amongst each other as our agency. Again, with the future iterations being something where there would be self play involved, the simulation would run thousands of times with that reward system in place, being preserving infrastructure and putting the fire out as quickly as possible, and there being some agency on top of the drone tower deployments there.
Got it. Got it. So it's okay. That's feature improvement section. I can see itself play reinforcement learning. That's what you mentioned. Um, at present, you didn't use any AI here.
Yeah, at present there is no AI. It's again just like a brute force algorithm where some of the nodes, like the drone towers, start talking to various nodes, neighboring nodes.
Okay,
But it's nothing like AI controlling it or anything.
gotcha, gotcha. It's a simulation, some brute force mechanism to interact between the towers and channel accordingly. Okay,
Yeah, so there's like basically some proximity matching going on, between fire and neighboring drone deployment towers, with some understanding around basically where the infrastructure is, so that it can be dropping the retardant intelligently where it can be protecting infrastructure.
got it, got it. Yeah, that's cool. I will definitely take a look at it, the GitHub repo, and I'll let you know if you have any questions further. Sadhna, you have any questions?
No, not really. But yeah, it's a good presentation, and um,
I like the simulation, Kyle, by the
yeah,
way.
me too.
It
I
is
like
nice.
that. Yeah, it's nice. And
We
the way the problem is also very, you know, a good cause.
yeah,
With the recent LA fires, this was a very
Yeah,
good one to pick. So I
we
think I
honestly
like.
led into this because we thought that this would be a really cool one to be able to visualize in sort of a gamified way. Kind of helps get buy-in for people.
Mm.
every
Yeah.
time when you start this one, it's a brute force and randomized spread. Here, what's happening?
Sorry, can you
Can
repeat that?
you every time when you reset and start,
Hmm.
the fire simulation is a random, and
Yes.
and the tower interaction is a brute force, kind of a random too. Is that correct understanding?
Yep. And actually, let me switch over. And I know this is going to be a little bit weird, but maybe I've got it up. Oh, I do. Good. So there's a lot of actual kind of randomness in the simulation, in the sense that This is basically the PNG image that's being sampled to infer the topology. There's not really a lot of randomness going on there, but I will toggle this on. So this image also gets sampled to infer population density. Um, this came from some sort of map. I'd have to figure out where I got it from again. It was a Census Bureau map around population density, where basically blue regions, the darker blue they are, the more population dense they are. If it was green, it was kind of like more suburban. Yellow, almost no one lives there. And so we sampled that PNG to where basically, if it's like a blue area, there's a high probability that there's infrastructure there because there's a high population density there. So we at random throughout these kind of like blue areas, for instance, start dropping gray tiles, but again, increasing that probability based off of the population density. So this could be, of course, improved through, I think there's like a satellite called like Sentinel Hub, something like that, that actually labels,
Yep.
various things on the landscape and everything. But this was just like a really quick and dirty way to be able to move forward with the hackathon.
Got you. Got you. Did you
And
guys explore? Go ahead, Padma.
no, you complete, then I'll ask.
No, just my question is like, Kyle Pfizer, did you read about FireSat recently Google deployed for this purpose? Anything that you guys learned from that, how they are doing it? It's been, I think, week or 2 weeks it's happened.
I gathered some of what you said. I think there was just like some words and stuff missing from your question. I'm trying to piece together.
Just want to understand, did you understand this problem statement with respect to what Google is doing using their FireSat? I think 2 weeks ago, first of kind satellite, Google launched a FireSat. How they are solving this problem? Anything that lessons learned from there, if you read it in detail, that any correlation here that you would like to share?
Gotcha. So yeah, I mean, I think one interesting point, I would have to really double check this because it was a perplexity search that led me onto this and I didn't validate the source. So, don't quote me on this, but I think I did read somewhere that like the Palisades fire, there was basically like a 6-hour delay between the fire actually starting and like first responders being able to get there. But apparently we did have some fire satellites, and I don't know if it was like Google satellite or not, that basically did detect the fire within like 20 minutes of it having started. And to me, when I read into that, at least, that was like a pretty strong indicator that if there was some sort of like drone system to kick in, engage, and suppress, that the outcome probably would have been a lot different. I know one of the difficulties with the ground forces was that the Palisades fire was they were already stretched thin, right? It was peak fire season. Fire department was already dealing with a lot of other things, and the terrain in particular where the fire kicked off was hard for them to kind of get to, and that's like a whole nother variable where drones would be able to have the advantage, right? So
Got it. Yeah, makes sense. Makes sense.
Yeah, I agree. But how close are people to implement all this?
yeah, I mean, the technology, it was kind of funny when we were solving for this, right? It was like, wow, the technology really does feel like it's sitting there.
Right. But true. So some changes, I think people will take time to implement. And so no, could you go back to your simulation for my own understanding? So you show basically I want to see one without drones and one with drones is what you have shown us, right?
Yeah. Yep.
Right. Do you mind again showing that?
Yeah. So
So
this is without any drones.
right.
And a good kind of like pulse check for us too that the fire simulation was at least somewhat accurate is we can actually show the burn map, which I meant to play with the implementation to make this stand out better. But the outer edges of the actual fire kind of are shaped like the state of New York. Um, and most of the time when you run this simulation, you'll find you'll kind of get results like that. Another thing is that the Palisades fire burnt 56% of the infrastructure. And a lot of the times when we run the simulation, it burns close to that. Um, Again, like there's definitely some dials that could be twisted around just how the fire modeling works. But this could, with more time, basically you could run the simulation maybe 1,000 times or something and achieve statistical significance to understand, like, okay, every 1,000 times that this runs, a majority of the time, right, 56% or something burns, the infrastructure burns, and that could help kind of guide your sense as to your intuition as to like how accurate the modeling is.
Okay, so now go back to the, now I've seen this, so go back to with the drones. Do you
Sure.
mind doing the
Yep.
simulation with the drones? So how are you measuring that? Are you saying that the speed of the impact, or like now since all the pinks are drones, right?
So all the pink is fire retardant that has been deployed to try to preserve infrastructure, and you're seeing it fade out because over 48 hours, it wears off its abilities.
Okay. But even in this example, it is spreading, right? It should have stopped from spreading because you're now using drones and all this.
Exactly. So one of the points I definitely want to be keen on acknowledging is that the drones simply get overwhelmed at some point. Like it does a good job, right, preserving the infrastructure in the beginning, and then where it
Mhm.
starts falling short is when the fire gets so big. The current drone implementation is not doing a good job of defending, and part of the reason is like realistically, when the fires are going off here, a more intelligent system would probably be deploying drones out here in the distance, already starting to drop fire retardant. And one of the kind of like weak points of our brute force proximity based implementation that we have right now is it's all kind of worrying about like its locality when the fire is already within some distance of, like a drone tower. When again, a kind of more like AI orchestrated system would be able to see the big picture better and basically start deploying some of these drone towers further out at the edge. And that's where we think basically having that AI system basically performing self play with a reward mechanism, preserving infrastructure would we would expect to start seeing some of those behaviors where some of the towers further out would start kicking in and engaging.
Okay, correct me if I'm wrong. So what you're saying, even though you have not considered that in your current simulation, but what you're suggesting is having some drones ahead, like because even though it's not immediately, I know my cursor, you can see my cursor, but my point is like far off from where the fire started. Have, give those areas as a preventive measure, to drones should start protecting that area. So by the time fire reaches there, it won't be, either zero damage or less damage. And then, is that what you're suggesting through this
Exactly.
using agent?
Um, exactly. And there's of course going to be a constraint of the fire retardant having like a 48-hour lasting effect.
Hmm.
Um, and so there would have to be like some intelligence around like, yes, acting early, but also not acting so early that you're just wasting resources.
Can we take the some other environmental factors in the air or gas, or as the fire is reaching closer, some other carbon dioxide or some kind of gas percentage to decide that yes, and then maybe do a math of 48 hours there.
Yeah, I mean, there's a lot of different ways to slice and dice it. Again, I think the satellite for this would be like Sentinel Hub, but being able to really label what is present in like a satellite image at a pretty granular level of detail and assign like burn probability rates to those various things that you're labeling would definitely allow you to have a higher granular level of detail in terms of like the probability rates of something burning in a neighboring state to a tile that's already burning.
Got it. Okay, anyway, this is a very cool, nifty thought, and you guys have done a good job. I think I liked it. Yeah, I think I don't have any other questions. Ravi, I'm good.
No, no, I think I'm good. I will take a look at GitHub, Kyle. Uh,
Okay, thanks
What?
everyone. Thanks. Yeah,
Yes,
go ahead, Kailash.
thank you. I was just gonna say, 5 minutes after the deadline, I did incorporate 3JS to actually project this simulation in 3D. Um, I know it was past the deadline, but if you
It's
guys think
okay.
that,
We kept the deadline because see, this is a volunteer organization, and stop recording. Okay, let me stop it. So basically,